Hello and welcome to CS50 section 1. This week we're talking about C, so hopefully you've watched David's lecture on C before coming to this, and section will be a time for you to review some of the course content, get some more familiarity with that material, and also get to see some more pieces of code in action. So let's get started. So my name is Kelly. I'm the preceptor here at the college, and here is my email if you ever need to contact me. But yeah, happy to be here. So today we're first going to be going into some of these questions that might have come up for you while watching lecture. So why are we using C? How can we read and write code that includes things like variables, conditionals, and loops? Why do we care about data types in C? And what does it mean to compile a C program? So all of these things, hopefully you'll get a little bit more of these answers as we go on today. So first, before we dive into the code, wanted to give you a little bit more background using CS50.dev, which is our Visual Studio Code coding environment. So when you go to that link, you'll likely see a development environment like this. This is separated into your text editor in this top right corner. That's where you're going to be writing your code, having your different files open. On the left, you have your file explorer, which is similar to something you've likely seen before. That's where all your files will be, your folders, and that's where you can manage those. And then in the bottom window, we have your terminal window. This is where you'll be typing your commands, running your code, things like that. CS50 also has some special features that we've integrated into this VS Code environment, one of which is the CS50 duck at CS50.ai. This is CS50's AI helper tool, similar to the kind of feedback you'd get from a teaching fellow. The duck is meant to give you some assistance if you have any questions or want to talk things through. We also have this Style 50 button, and this is one of our axes that we grade code on. So style is referring to how pretty your code is, how legible, mainly for humans. So if you see this example on the right here, it's missing some spacing. You might have noticed that we usually like to have those curly braces on their own line. And so if you click that Style 50 button, what it will do is show you these two versions, your version and then the stylized version on the right. And you can also hit in the top right, explain changes, which will pull up the AI Duck Assistant and explain to you what changes were made and why we prefer those stylistic changes. Of course, this is also a subjective thing, so your idea of style might be slightly different than what we typically expect, but that's just to give you a look at what changes we expect. You can also hit apply changes in that corner, and that will fix your code for you. We also have Design 50. Design, again, is another one of these axes that we grade things on. And design is referring to how well does your code actually work. So it might be correct, it might do all the things it's supposed to do, but is it efficient? Is it doing what you want in an effective way? So if you hit Design 50, that will give you, that will pull up CS50.ai and give you some feedback on your code. We also have this Explain Highlighted Code feature. So if you highlight any pieces of code, maybe from the distribution code you're not sure about, you can highlight it, right-click it, and click this Explain Highlighted Code bit, and that will, with CS50.ai, explain to you what that piece of code is doing. All right, so let's get into some of the nitty-gritty of C with variables, types, inputs, and printing. All right, so like you've seen last week in Scratch, we had this when green flag clicked, say hello world. It's a pretty basic Scratch program, and it had the effect of this Scratch cat saying hello world. This week, we're transitioning into C, which is this more text-based language, but these two things are still doing the exact same thing, despite the one on the right looking a little bit more cryptic with a little bit more syntax. But hopefully over the course of this week, you'll get a little bit more comfortable with seeing this and understanding what that means. To just demystify some of the things you might already be wondering about, int main void is, you can think of the equivalent to this when green flag clicked block. So that's what function that runs when you compile a file. And so similar to the when green flag clicked, that's the code that will be run. Next, we also have header files. And so this hashtag includes standard.io.h. This is what we use to import libraries. So standard.io.h is a library in C, and it contains a lot of different functions, one of which is the printf function. So when we want to use printf, we also have to make sure we include this library. If you're ever wondering about what functions are included in what libraries and what sorts of functions you have available to you, you can always go to manual.cs50.io, and this website has some of the more frequently used functions and the frequently used libraries that we like to use in CS50, and they give you some explanations on what inputs these functions take, what they're used for, and how you can get started with using them. Okay, so let's talk about using variables. So you might recall this Scratch program from lecture. If you see here, it's slightly different from the one that you saw just a second ago. We have when green flag clicked, set name to David, then say join hello comma name. So what we're doing here is we have a name variable, and we're setting that to the value David, then saying hello, and then whatever's in that name variable. That has the side effect of the Scratch cat saying hello David, as we'd like. And so this idea of having something like name that has some sort of value associated with it, that's what we're trying to do with variables. So we can do the same thing in C. Of course, it does look a little bit more cryptic, but hopefully you're seeing some of these parallels between these. So we have this line 6, string name equals David, similar to set name to David, and then printing hello with that name variable. And we'll look a little bit closer at what this line actually means. So going back to this idea of a variable, we can deconstruct it like this. You have string name equals David, semicolon. And you can think of this as just creating a variable, that's that little box there in the corner, called name, that stores the value, a string called David. So I first want to ask, you can take a second and think about this for yourself. Why does C care about data types? A data type, in this case, was a string. So we can think for a second, like, why do we need to even mention that it's a string? Why is that important? I'll give you a second to think about that. So if we remember that all information in computers are stored in bytes, which are, for example, this is a byte. We also remember that this could represent a number, like an integer, in this case 65. At the same time, the same byte could also convey the capital letter A, right? We remember with the ASCII table, we've assigned certain letters to certain numbers, and that's how we know whether or not something is, say, a char or a integer. So these things can have different meanings in the computer, and so it's up to us to tell the computer, hey, this is supposed to be a letter, or hey, this is supposed to be an integer. Okay, so let's move on to another example here. Let's say you were trying to create some sort of personal wallet tracking finance app. One of the variables you might need to keep track of is like a person's balance. How much money do they currently have? So let's create a variable for that. Maybe we call it balance to say like, this is how much money I currently have. And balance here is the name of the variable. Integer is the type. So I've set this to be an integer type. And then I've set the value of this variable to be 20. Here, something to note is that while we normally think of equal sign in like everyday language as like this thing equals this thing, here we want to think of it as an assignment operator. So we're assigning the value on the right, 20, to the variable on the left, which is balance. So in all, when you look at this statement, you can think of it in plain English language as create an integer named balance that gets the value 20. Another question you might think about is, why does our choice of data type matter? So in this balance situation, why might I pick int? Why might I pick a different data type? And what's the consequence of that? So you can think about that for a second. Something you might be noticing is, sometimes I don't always have like exactly $20. Maybe I have like 50 cents. And an integer may not be the best type to represent that. In this case, maybe I decide, oh, balance should really be a float. That way I can capture the decimals. So all of these decisions are things that us programmers are going to make while deciding like what is best for this variable in this situation when I'm trying to use balance to convey certain information or do certain things with. All right. And so the first line here in balance equals 20, that's what we usually do when we're assigning a value to a new variable. But if we want to go back and update that, so maybe you pick up $5 on the ground, you also want to be able to update that variable. So balance equals 25, we'll assign, right, with the equal sign, that's our assignment operator, we'll assign 25 to the variable balance. Okay. We can also do a number of operations on our variables, just like how you've normally done in math. We can increment. So if I wanted to add 1 to balance, I could do balance equals balance plus 1. Or another easier way, quicker way of doing so would be balance plus plus semicolon. So both these things will increment balance by 1, but the bottom one is usually what people will use if you're trying to increment just by 1. Same thing can be said for decrementing. So if you want to subtract 1 from 20, then you could do balance equals balance minus 1 or balance minus minus. Both do the same thing. We also have multiplication. So same as usual, if I wanted to multiply balance by 20, by 2, then I can do balance times 2, or I could do balance times equals 2. And so those two lines will do the same thing. Similarly, we have division. So balance equals balance divided by 4. That will set balance to 5, or you can do balance divided or slash equals 4, and that will also give you 5. Another thing to note here, let's say you have integer balance equals 20 and you're dividing by 3, what is that going to return? So if you were just doing the math, you might have like a decimal value, but what is this going to be You can think about it for yourself in a second. So what this balance variable will end up being is actually 6. And why is that? Why is it not 7 or some decimal value? Well, this slash, which is our floor division, when done on integers, is going to round down, even though it may be closer to the next highest number. And so that's something to note, especially when you're completing the cache portion of the problem set. So something to note. This depends on operators. What they are doing will depend on the type. We also have this operator called the modulo operator, so that's the percent sign here. If you haven't seen this before, it basically gives you the remainder of the variable you're working with. So if I did balance equals balance modulo 6, basically we're saying what is the remainder when I divide balance by 6. So in this case, 20 divided by 6, you have, it fits into 23 times, but we have 2 left over, so we get balance equals 2. All right. So in all, we have these operators. We just looked at a lot of these top operators, plus, minus, multiply, divide, and modulo. We also have some relational operators, which you'll see when we're trying to create like Boolean expressions, and logical operators, which also come into play with creating Boolean expressions. Okay. So we've seen that we can set values to variables, like balance equals 20, but let's say we wanted to get input from the user. So in this case, we've used a getInt function, which is something included in CS50.h, and we have the integer type, again, balance is the name, and then we're assigning it to not just a value now, it's the value that this function, getInt, returns. So getInt will prompt the user to enter a balance, and that value will be stored in the variable called balance. So again, getInt is the name of the function, and then this is the function input. So getInt, you can look at the manual for this, but getInt will take in a string of like what you want the input to say before the user types in what they want to put the value as. All right. So if we're printing out this balance that was given to us, or we have stored in a value, we might have a print statement that looks a bit like this. So we have printf string current balance and then $% %i \n. So that combination of characters, we'll talk about what that means. So %i in this case, we're calling it a format code. This format code is basically acting as a placeholder that will be substituted with the value that we want to use. So in this case, balance is an integer, which is why we're using the format code %i as a placeholder, and then it will be substituted when it's printed with balance, the value of balance. There are different kinds of format codes you can use depending on the type of variable you have. And so that's just something to note if you're trying to print something out of a different type. All right, so I've done enough talking here. Let's try to move to our actual coding environment and see how these things work in code. So we're gonna move to our CS50.dev coding environment, and we're gonna try to tackle this first part of the problem set, which is just a simple hello world program. So I'm gonna first start out by creating this file, so code hello.c. So this is creating a file called hello.c. Now up here in my text editor, I can write out the code that I want. So I remember we're gonna start out with int main void, And then I want to print out hello world. Okay. Let's try that out for now and see what happens. So I do /hello, or first I have to do make hello to compile this program and see what error is popping up here. We have call to undeclared library function printf. So if you recall, printf is one of these functions that come from a library. And so in order to use it, we have to make sure we include this library. And you can see that the error helpfully gives us that as a reminder. So I'm going to include standardIO.h to recompile. Great, no error. And then I run /hello. We have hello world, but my terminal is starting out on the same line. So what might I want to do here? I think I should add \n to give myself a new line. That way I will start on a new line. So, oops, okay. Gonna make hello again, /hello, and it prints out hello world as we hoped. Great, so that's our first step here. We're gonna move now to a slightly more complicated version of this program, which is hello, it's me. So when we run this program, our goal is to ask the user what's their name, and then print out hello, comma, their name. All right. So I'm just going to make some edits to this program. First of all, I know we want to ask the user for some input and store that in something like a variable, right? So I'm going to start out with string. Maybe I'll call it name. And we're going to get input using getString. And something to note here is getString is one of these functions that actually are included in CS50's library. So I need to make sure that I include that here. Okay. So I'm going to pass in an input to this getString function. So let's say, what's your name, ? And don't forget that semicolon. And so now let's see what happens here if I make hello, /hello. So it asks me, what's your name? I'll put Kelly. Okay, and it's still printing out hello world. We have some improvement to do here, but that's a good start. So I know that we want to print out hello and then my name instead of world. What if I just put in my name here? I already know my name, so I could say make hello, /hello. What's your name, Kelly? Hello, Kelly. So at a first glance that works, right? But if I were to run this again and my name was not Kelly, maybe it's David, it still says hello, Kelly. So I'm not really supposed to be hard coding this variable, right? That's hard coding means that I'm just giving it the information that I want it to rather than having it as something that dynamically will change, like my variable. So what I should be doing here is replacing it with our format code here, %s, because it's a string, and then passing in this value, name, which is what will be put in where that placeholder is. So let's make this again. What's your name? Kelly. Now it says hello, Kelly. I'll try it again with David. And now it says hello, David. So that is what we were hoping for. Okay. So let's come back here and try out one more exercise. This is a program called Contacts. We're going to ask the user for a name, an age, a phone number, and then maybe another value of your choice. So I'd encourage you to pause here, take a second and try to figure this out on your own before coming back, and we'll do it all together. All right, so let's move back to my CS50.dev. I'm going to code contacts .c to make a new file for this. And the first thing I'll do, as always, is include those libraries that I need. So standard.io.h. I also want CS50.h. And now we can start with our main function. All right. And now we know that we want to be prompting the user for certain things, right? So we had name, age, phone number, value for choice. So I'm just going to make a note of this to myself. So these 2 slashes I just did created a comment. And these are things that will help you along the way read your code a little bit better, will help other people who are reading your code, but it doesn't have any actual effect on your code. So I'm going to do name, age, phone number, and maybe location. So first getting the name, this is similar to what we just did before. Let's say string name equals get string name. And then I'm going to ask for an age. Let's say that's an integer age. Okay, then we have a phone number. Well, a phone number is a number, so maybe I'll just put that as an integer. Get int phone number. And then we'll have location as a string. Just get string, ask for location. Okay, so I have all of these building blocks to get these inputs from the user. So let's try that out for now, see what happens. Make contacts, / contacts. So I'll ask for name, Kelly, 21, my phone number, 111. Okay, let's see. So it's prompting me again, which makes me think something's going wrong here. Why am I not able to put in my phone number? Well, first of all, I forgot an extra number on the end here, but really we should be seeing here that this is including some, like I have hyphens, some brackets, which do not really, aren't really compatible with an integer type. So what I might want to do here is actually change this to be a string. Change this to get string. So let's try this again. I'm going to make contacts and then run contacts. It'll ask me my name, age, phone number, let's say. Okay, great. Location, Cambridge. Okay, so it takes in those inputs without any errors, as we can see. And now we want to be able to output that and print it back to the user. So I know we want to print, and what we might want to say here, say new contact, name, age, lives in location, can be reached at phone number. So new contact. And so my name here is going to be a string, so I'm going to put a placeholder there. And then my age, which is an integer. So this should be a string placeholder, integer. Lives in location, which is a string, and can be reached at my phone number, which I've now changed to be a string as well. Okay. So we have the string portion of this. Now we want to give it those values to substitute in. So the first one here is going to correspond with name, and the order that I put these in will correspond with the order that they're substituted in. So I'll have name, age, location, and then phone. All right. I'm also going to add a new line here, so that it goes onto a new line. And let's try this again. So make contacts, / contacts, name, Kelly, age, phone. location. All right, and then we have new contact, Kelly, 21, lives in Cambridge and can be reached at 111111111. Great. So now that we've gotten some practice with printing variables and getting input, let's move on to some more things that we can implement in our code. So we're going to talk a bit about loops and conditionals now. So conditionals. This is, we want some code to run, but only under a certain condition. In this case, going back to our wallet or personal finance app example, let's say I want to print out the balance, but I only want to do so if the person's balance is actually a positive number. So I have this statement here. If balance is less than 0, print insufficient funds. And let's break down what each piece of this does. So this section here is what we call a Boolean expression. That means that whatever goes inside of those parentheses, it's going to evaluate to be either true or false. In this case, whether balance is less than 0 will evaluate to be either true or false. This is what the portion of it we call the conditional, the if. And then this statement is going to run if this Boolean expression evaluates to true. We can extend this a bit further and then provide another case. So we have this first case, if balance is less than 0, we'll print insufficient funds. If the balance is not less than 0, which is our else case, then we can print available balance, and then later maybe we'll print out the balance. So something to note here is that these two cases are mutually exclusive, right? You're not going to have a balance that's both negative and not negative. And so these two cases are never going to be happening at the same time. We also have for loops. This is if you want to do some sort of action, do something a repeated number of times. And for loops especially are helpful if you know exactly how many times you're going to be doing that thing. So in this little example here, we have a for loop that prints out, I can count to 1, I can count to 2, I can count to 3, all the way so on until I can count to 30. So let's break down each part of this syntax, as it can be a little bit overwhelming at first. So this first portion is what we call initialization. So this is, I is sort of our variable that's keeping track of which iteration we're on. And so I first need to actually declare that variable. So I'm giving it int I equals value of 0. Then we have another Boolean expression like we saw in the conditionals. And this is specifying when am I going to repeat until. So as long as this expression is true, I should run the code that's within this for loop. So as long as I is less than or equal to 30, then this printf will print. Then we also have the incrementing step. So this means that every time I run printf, every time I run the code that's within these curly braces, the I variable is going to increment by 1. Okay. We can do a similar thing with while loops, but the use case is a little bit different. So with while loops, we don't necessarily know, this is good for situations where you don't necessarily know how many times you're gonna loop for, but you know when you should loop until. So what does that mean? Similar to for loops, we have the first initialization part. You know, we've set some sort of counter variable, or in this case, we just have I, and we've given it a value of 1. Then within the while loop, we have another Boolean expression. And so as long as this expression evaluates to true, then the code within those curly braces will run. And so while I is less than or equal to 30, this thing will loop over and over. And then we also have the increment step like we saw in the for loop. But in the while loop, this is going to be something that you also have to do within your while loop. You can imagine that if I wrote this while loop the same way, but I forgot to add that I++ step, it might just run on forever, right? Because I is not going to change its value, and therefore I, if it's always 1, will always be less than or equal to 30. So that's something to note if you see yourself maybe accidentally making an infinite loop. Okay, a third type of loop we have is what we call the do-while loop. So this do-while loop, it looks a little bit similar to the while loop, but we have this do and notation beforehand. And so the main difference here is that with a while loop, we start out by evaluating this Boolean expression. So we first check before we even run printf and I++, is I less than or equal to 30? In a do-while loop, we don't do that initial check. We first will start out by doing what's in this do block. So I have int n, and then I will set n to the value of getInt. And then I'm going to check while this condition, n is less than or equal to 0. While that's true, I should go back and do that again. And so you can think of do-while loops as having this extra piece of code that will run no matter what. You don't do that initial check compared to while loops. Okay, so now we're going to move on to Mario, taking a look at what we can try to piece together from what we've just talked about and get started with this week's problem set. So if you're familiar with Mario, this is a video game, and this is one of the first few games, I think. In the game, we have one of these block pyramids, and we're going to try to replicate something like that in this week's problem set. So we have this like pyramid of hashes where each level has one less hash than the next. All right, so we can try by first creating a left-aligned pyramid. So this might be a little bit easier than what's asked of you in the problem set, and this will hopefully get you more comfortable with starting out. Okay, so let's move to CS50.dev. I'm gonna clear my terminal, and we're gonna code mario.c. Okay, so first things first, we should include those libraries that we need. So I know I'm going to be using getInt, so I should include cs50.h. I also know I'm going to be printing, so I should include standard.io.h. And then I have my main function. All right. So a good tactic to think about when you're like starting out with writing a program could be to like outline what are the like step-by-step things that are going to happen in this program. When you're first looking at this empty code space, it can be a little bit daunting. Like, what am I supposed to do first? So sometimes writing that out step-by-step is helpful. So I know that first I'm going to be like prompting the user for a height, and that's going to be like an integer. Once I get that height, I know that I want to print out the pyramid of that height. Okay, so that's kind of how we're breaking it down. We have two big steps. First, we're going to prompt the user for the height. Then using that height, we're going to print a pyramid. So let's tackle this first part first. So if we recall from getting inputs before, I'm going to create a variable called height. It's going to be an integer. I'm going to use the getInt function. to get that from the user. So I'm going to say height, and then this will ask the user for the height. Okay, next we have printing the pyramid. So this is a little bit more complex of a task. So another way we can tackle this is just like try some things, iterate on that, and improve as we go. So I know that I want to print something over and over again. So this might be a good chance to use a for loop. So the height of my pyramid is going to be the variable height. So I can set out my initialize I to 0, let's say, and repeat as long as I is less than height. Each time I'm going to increment I. And so hopefully this should print out something a height number of times. So let's just do one hash block for now and see what this does. So I'm going to make Mario, /Mario, height, let's say 5. Okay, so we have 5 hash blocks here that we're getting somewhere. That is like the height, but I know that these should be on different levels, right? So each time I print this row, so let's say this is like my row, I should also be printing out a new line. Okay, so if I make Mario again, oops, I forgot an F there, so make Mario, /Mario 5. Okay, so we're getting somewhere, right? We have our 5 rows, but within the row, we don't want just one hash block. We want some number based on what the height is. And so when I have this like mini problem within this larger problem, right? Like somewhere in here, I should be like printing the row based on like the height, or based on, I guess, specifically which row I'm on. I can sort of what we call abstract away this into another function that solves that mini problem for us. So I'm going to say, let's create a new function called print row. And all this is going to do for us is, given how many hash blocks we want to print, we'll print out that many. So given a number of bricks, print that number of bricks. So I know I want to take in some number. I'm going to call this bricks as an input. And then print F. I want to print brick number of bricks. So again, we can use this for loop. I equals 0. And I can use I again because it's only the scope, as we call, of I is only within the for loop. So when I'm outside of that for loop, I can also use I here. So I'm going to say I is less than bricks, I plus plus. And then within that, I will print F to 1 hash. Okay, and then at the end of the row, so let's say I've printed like 3 hashes, 3 bricks, I want to also print a new line so that the next row does indeed start on the next line. Okay, so now instead of this, I can use my new function that I just created and do print row, maybe height number of bricks. Seem right? So now let's see what happens when I make Mario. Okay, so we get this error called call to undeclared function. So I've created this new function, but because I'm calling it before it was actually created, we're getting this error. So there are two ways I could fix this. Like one way is I just move this up here. Now if I run it again, print F. Okay. Now if I run it again, no errors. The other way that we tend to recommend is to prototype this function. So basically taking this first line here, copying it up here, adding a semicolon. And what this does is it tells the compiler like, hey, I'm gonna have a function called print row, and you should just trust me on that, but it will be coming to you later in the code. This way, it's nicer because we have our like main code up at the top, and it's not cluttered by these so-called helper functions. And so this is just a bit of a cleaner way to do it. So I'm gonna make Mario again, and we're gonna run, say my height is 5. Okay, we're getting somewhere a little bit closer. Still not quite right though. So I now have 5 rows, which is great because I've repeated this 5 times based on the height. And then each row I'm printing, I've passed it in with height, which is 5, number of bricks. So that's not quite right? We want the number of bricks printed on each time to depend on like which row we're on. So if I'm on the first row, I should print 1 brick. If I'm on the second row, I should print 2 bricks, 3 bricks, and so on. So instead of height here, instead of printing out 5 in each row, this should really depend on my variable I here. So I on the first row is gonna be 0, then 1, then 2, then 3, then 4. So if I run it like this, let's see what happens. Okay, so it's looking a little bit closer to a pyramid, but I am getting nothing on this first row. You probably maybe have noticed this when I was speaking, but we set I to be starting at 0. And so in this first row, we're printing 0 blocks or bricks. So what I should do here is somehow print 1 more than what I is. So I could say, print out I plus 1 bricks. So we make Mario, /Mario, 5, okay? And that is looking a lot better. Another way we could have done this, which is also just as valid, is maybe instead of editing I here, I actually start the pyramid at 1. And then instead of ending 1 before height, I could say go until I is less than or equal to height. So this way it's still printing or repeating the same number of times, but I don't have to edit I here because I'm actually starting I at 1. So if we run this again, we'll see that it still works the same. And if I tried it with a different number, let's say 8, okay, awesome. Now it's like, now that's looking like what we want it to. I'm gonna try one more thing. Let's say I give it a height of like -5. Okay, it's not doing anything, which is fair because you can't really print a -5 height of a pyramid. And so potentially what we want to do here is actually re-prompt the user when they give you a height that can't be printed into a pyramid. So if we recall, one of the loops that we talked about was a do-while loop. So this getting input from a user is a good situation to do this because we want to actually first prompt for the height. So first do this step and then check if it's not a valid height. So I'm gonna initialize height as a variable. Then we're gonna have do something. while something else is true. Okay, so first thing I want to do is say height should be equal to what the user puts in as height. And then this block, we're saying while some condition is true, you should go back and repeat this step again. So when do I want it to repeat that step again? Let's think. When the height is, let's say, less than 0, I should just ask the user for a new height. So I'm going to say when the height is less than 0, or I could even say less than 1 if you don't want to print out a pyramid with 0. We can say while the height is less than 1, do this over and over again. So let's test out how that works. So if I do make Mario, then Mario, it works normally if I do a normal height. If I give it -5, for example, we can see that it is prompting me again, which is great. If I keep giving it negative numbers, -9, -10, it's going to keep re-prompting me until I give it something valid like 3, and then it'll print it out for me. Okay, great. So you're well on your way to completing this first part of Mario and the first part of the problem set. And let's just talk a little bit more broadly about what we just did here. Specifically with this print row function. So if you think back to our description of functions as like a black box, we have this box here that we've titled print row. And this box, which is our function, is taking in an input of the number of bricks we want to print and outputting that printed row of bricks. So for example, if I gave it 3 as the input, then it printed out 3 blocks. And so that's really great. That's really great to have in your program as a way to, again, abstract a certain part of that code away. You could do this exactly the same if I, say, moved this into my main function and printed each row within this main function. Like that also works really well. But abstracting away this functionality into a separate function is one way of making your code potentially more clean, more readable, and easier to see where things are going, what's going on, without making the code super long. So this is a technique that you're going to continue to use throughout this course, and hopefully that gives you some more intuition on when it might be helpful to create a function. All right, so that was CS50 Week 1, Section 1 on C. If you have any questions, feel free to use our resources, email me if you need to, and I hope you have a great day.